In this lesson, we'll be talking about TCP. TCP is the Transmission Control Protocol. It's part of the TCP/IP suite of protocols, and it's a transport protocol. That means that it sits above IP, or the Internet Protocol, on the OSI model. IP, as you may know, is at the network layer, and the transport protocols sit on top of the network layer. Like UDP, TCP uses ports to differentiate networked applications. Unlike UDP, however, TCP is connection-oriented. TCP uses a three-way handshake in order to establish a connection between a sender and a recipient. In part, this connection establishment ensures reliability, and it does that by making sure that the two parties can hear each other and that they're talking the same language. In the real world, that might look something like two people meeting in a street, and the first person says hi, and the second person says, "Hi, how are you?" And the first person replies with, "I'm great." So what you get there is the first person saying something, the second person hearing that and acknowledging it with a response. The first person then knows that what they originally said was heard, understood, and received a reply. So the three-way handshake in TCP looks like this. And I've got a Wireshark capture up of some traffic that was on my network earlier. Right here I've got a SYN message, which is the original hi. So that's the opening of the three-way handshake. We send a synchronized message. And if I look down here in the flags for the TCP header, I see that the SYN flag is set. In order to ensure that the SYN message was heard, the second party sends back a SYN ACK, or a synchronized acknowledgement. So if I go to that message in my Wireshark capture, I see that the flags ACK and SYN, or acknowledgement and SYN, are both set here. So that's the "Hi, how are you?" Now we just need to make sure that we get a message back from the recipient back to the original sender, and that's this message here. That's the ACK, or the acknowledgement. So no other flags, just the acknowledgement flag. So with that ACK message, we know that the first person or computer can send a message to the second computer. The second computer can receive that message and reply to it, and the first computer can receive and understand that reply. And because of that, they know that there's a reliable connection between them, and so we have a full connection up. So from a reliability standpoint, we ensure that the recipient is there and responding, and for the recipient, it ensures that the sender is still there after the original message was sent. Without that acknowledgement back from the sender, what you can end up with is half-open connections. You'll hear these mentioned sometimes. They're called SYN floods, and what happens is you can send a SYN message, and the receiving computer will open up a piece of memory called a buffer in order to hold open that half-open connection, waiting for the three-way handshake to complete, at which point it has a full connection. Now, for every computer, there is a limited number of connections that it can handle at any given point, memory not being an unlimited quantity. So if I keep sending a lot of SYN messages and never finish the three-way connection, I can start filling up the buffers on the receiving computer, and that's exactly what happens with a SYN flood, is the buffers in the kernel space memory begin to fill up, and it no longer has the ability to receive legitimate messages. So this is one of the downsides of having a reliable connection. You have to go through this three-way handshake, and because of that, you end up with the possibility of a denial of service where your memory buffers are exhausted by somebody sending a whole lot of synchronized messages or SYN messages. So let's take a look at some of the other headers that come along with TCP. And since we've got the flags section open here, let's just look at the flags. We've got an echo flag, an urgent flag, acknowledgement, push, reset, SYN, and FIN. For the most part, the ones that you're going to see used are the acknowledgement, the reset, the SYN, and the FIN. And we've looked at the acknowledgement and the SYN. The reset is used to reset a connection. So, for example, if I were to send a SYN message to port 83 and port 83 wasn't open, the receiving computer would send back a reset to me to indicate that port 83 was not open. The other flag that you'll see pretty regularly is the FIN flag. And the FIN flag is used to tear down connections, so it's kind of the opposite of the SYN flag. Now, unlike the three-way handshake that's used to set up a connection, a teardown is actually 4 messages. So what happens is both sides originate a teardown, so both sides will send out a FIN when they're tearing a connection down. And then the other side or opposite side will acknowledge that FIN. So you'll send a FIN to tear down the connection, you'll get an acknowledgement back. The other side will send a FIN and you'll send an acknowledgement back. So there's 4 messages to tear a connection down, unlike the 3 that are used to set it up. So some of the other headers that we've got with TCP, you see the source port and the destination port, obviously. Again, we use ports to differentiate networked applications. So once you've got to the computer, which is the IP address, you need another address to differentiate which application you're talking to, and that's done using ports. So in this case, we've got the destination port of 80, which means I'm talking to probably a web server. I've got a sequence number, which makes sure that the messages are put back together in the correct order. I've got an acknowledgement number, which has to do with while the communication stream is going on, the receiving computer continues to send back acknowledgements to let the sender know that it has received the messages that have been sending. And it does that to make sure that we continue to have a reliable connection. In other words, the messages that are being sent continue to be received. So we have to keep sending acknowledgement back. We have a window size value, which again goes back to that reliable transmission. The window size has to do with the number of bytes that I can send before I have to wait for an acknowledgement to be received. We have a checksum, which ensures that the message that is sent is actually the one that's received. In other words, it hasn't been altered in any way in transmission. And then we've got a set of options flags, which include a timestamp value. And the timestamp value can be used for a handful of things, which we'll get into in another lesson. But that's a quick overview of TCP and the headers and the various ways that TCP works.